Hello and welcome. This is a walkthrough of the Chemistry Regents exam that was given on June 22nd, 2011. What's going to happen in this tutorial is that we're going to walk through Part A of that Regents exam. And Part A of the Regents exam is a section of multiple choice questions. There are 30 questions in all, and they cover the full scope of the entire course. The section is chopped up according to its topic area. And you can see that we've highlighted here the first section, which is the section dealing with atomic structure. And our first 4 questions all deal with atomic structure. So we'll jump right in with question number 1. A neutron has a charge of. Well, that's a super simple question. If you have some background here, you know instantly that that is going to be the charge of 0. But let's look at the details of where this comes from. There are several atomic particles that we discuss. You have the proton, the neutron, and the electron. And if we break up this and form a little chart with this information, we can talk about the charge of each of these particles, the proton being positive, the neutron having no charge, and you of course recall the electron with negative charge. An additional piece here we're going to fill in dealing with the size of the particle. This is going to help us answer the next question, just to make our chart a little bit more complete. Hopefully you all recall that the proton has a size that's related as 1 atomic mass unit. The neutron has an equivalent size, also 1 atomic mass unit. And your electron is super small, coming in at only 1/1800th the size of the proton or the neutron. Okay, that brings us to question number 2. Which particle has the least mass? Well, of course, from this chart over here, we're looking for the electron, but we don't see it. But it is hiding there. We have the proton and neutron. Notice that they're the same size or the same mass, so we're going to exclude those 2 answers because they're the same. Now we do have to have a little bit of understanding of what these 2 particles are, and that's going to require knowledge of the nuclear chemistry unit. Hopefully you recall that the alpha particle has a charge of +2, and it is emitted from an unstable nucleus in some atoms when they discharge the alpha particle, which gives off energy. And the size of the alpha particle, the symbol for it, is He4/2. So you can see it's huge. It's equal to 4 times the size of a proton or a neutron. That's what an alpha particle is. That obviously is not our answer either. That leaves you with only the beta particle. So 2 is going to be your correct answer, but let's make sure we understand what a beta particle is. We'll put that on our chart of atomic structures as well. The beta particle has a charge, usually a negative charge, but there are also positive beta particles. They're called negatrons and positrons. And the beta particle is also the size of an electron, and its symbol is E0/1. The top number here designates the mass. The bottom number designates the nuclear charge. So the beta particle, being the size of an electron, is exactly what we were looking for in this question. For question number 3, a sample of matter must be copper if. Well, we need to track down some information about copper to see which one of these statements is going to match it properly. So to do that, we're going to bring up the reference table. This is the periodic table, and very quickly we're going to find copper on here. And you can see copper's location right here on the table. So I'm going to snap that little picture out, and I'm going to insert it into this page. Here's my little copper sniplet. And we're looking for information related to the copper so that we can answer the question. Each atom in the sample has 29 protons. Now hopefully you recall that the piece of information that tells you the number of protons is the atomic number. The atomic number is designated on this little cutout from our periodic table by that 29 right there. And since that number is 29 and each atom in the sample has 29 protons, it's a perfect match. That one is your answer. It's telling you exactly what each copper atom has. Just to make sure we didn't make an error, let's rule out the other three answers just to be thorough. The sample can conduct electricity. Is this true? Yes. But all metals conduct electricity. So copper is not unique. The sample melts at 1768 K. Take my word for it. If you go and look this up on table S, which we won't do just yet, you'll find that the melting point of copper is not 1768. That's the melting point of cobalt. So they were trying to fool you because the symbol for cobalt is CO, and they're hoping that you're going to look up CO for copper on table S, and you will see 1768 and make a mistake there. Atoms in the sample react with oxygen. Hopefully at this point you realize most metals will react with oxygen. So that again is not unique to copper, so our only correct response left is number 1. Question number 4 is one of a number of questions in part A that rely on your understanding of a definition. Here the definition you need to know about is the electron cloud model of the atom. Just think about the words electrons, clouds. Where are the electrons? They are in clouds. This clearly is talking about the location of the electrons, not the charge, which is -1, not the conductivity of an electron, where electrons moving in mass are considered to be an electric current, and not the mass of an electron, which is 1/1800. So clearly this answer is talking about the location of the electron. The next segment of the exam is questions 5 through 8. Generally speaking, these relate to the periodic table of elements, but they do also relate to properties of the elements. Usually these two things are discussed in the same basic area. The elements in the periodic table are arranged in order of increasing. Well, there are two possible answers for this. If we're talking about the modern table, which we assume we are here since it does not say the original table of elements, the modern table arranges elements according to their atomic number. So we already know our answer. There it is. Number of isotopes, never. Number of moles, never. Number of moles, not related. Isotopes, not related. Mass number, this would be the correct answer if they were talking about Mendeleev and the original periodic table. So for this question, that's not going to be our answer. Which element has the highest melting point, number 6? Well, who knows? These are strange elements. These are not ones that we normally talk about in class. The purpose of this question is to force you to look on table S and find these 4 numbers. So let's do that. We'll bring up table S for you, and we'll try to find these elements in the picture. Well, first thing you're going to notice is that they're obscure. I have to scroll down and really hunt for these elements on this table. Fortunately, they've chosen 4 examples that are all in the same basic area. There they are. So our goal, since the question is asking us which has the highest melting point, is to simply read the melting point, that's in this column, and pick out the one that has the highest value. So let's start with tantalum. Tantalum is 3290, rhenium 3458, osmium 3306, and then we have hafnium, which is 2506. So all I got to do is pick the highest number, 3458, and that's going to be rhenium. Let's return to our question and circle rhenium. Question number 7. In a chemical reaction, there is a conservation of. We have a bunch of choices here. What we have to do is search for the answer that has the 3 things that are conserved and cross out the items that are not conserved. Volume, not conserved in a chemical reaction. Oh, look at that. Just by spotting the one thing that is not conserved, we found our answer. Let's move on. At standard temperature and pressure, don't forget, that's what STP stands for. Let's make sure we remember that. Standard temperature and pressure. It might be helpful for us to remember what those values are. The standard temperature is 0 Celsius or 273 K. And the standard pressure is noted in a lot of different units. We'll stick with the 101.3 kilopascals for now. At any rate, since we have standard temperature and pressure, we have 2 types of carbon. You have diamond and you have graphite. Both of these substances are composed completely of carbon, and yet they are very different from each other. So we have to find the statement that matches here. Why are they different? Well, they're different because they have different crystal structures. So answers 1 and 2 are out based on the crystal structure comment. And then, do they have the same properties or are they different? Well, try giving your significant other a graphite ring and you'll find out that they do have different properties. That's answer number 4. Question number 9 sets off our math alert. This is a mathematics question, a chemical math question. We're dealing with the gram formula mass, and we're dealing with a quantity of 1 mole. It is convenient to know that the gram formula mass is represented in units of grams per mole. So if you have 1 mole of a substance, and you know that it has a mass of 48 grams per mole, then all you have to do is multiply the two numbers together and you'll get your answer of 48 grams. So 48 grams per mole times 1 mole. This works because the mole cancels out and your answer is left with 48 grams. Question 10 deals with bonding. Here you have a chemical equation that clearly shows a molecule of chlorine, which is really 2 chlorine atoms attached to each other. That's what the Cl2 represents. And they undergo a change, and now we have 2 Cl's separate from each other. So somehow that attachment disappeared, came apart. So what we are going to refer to here is the fact that a bond is being broken. It certainly is not being formed. Now, since any time a bond is formed, energy is released, that's a definition, then we must assume that when a bond is broken, energy is being absorbed. That's the bond energy of the molecule. So answer 1 is your best response. For your next question, number 11, which atom has the weakest attraction for the electrons in a bond with hydrogen atom? Well, this whole concept of attraction for electrons deals with a concept called electronegativity. And the idea of electronegativity, we can look that up on table S for these 4 elements. So when we do that, let's go to table S, which we still have open from our previous question, and we'll find our 4 elements and we'll write down those numbers and then we'll compare them to each other. The first one is chlorine. That number is 3.2. Fluorine, 4.0. Here's your fluorine up here. Then we have oxygen weighing in at 3.5. This chart actually has 3.4. They've changed that value on the 2011 reference tables. And sulfur, clearly the smallest number at 2.6. So we're going to pick sulfur because it is the lowest number. Again, this was 3.4, this was 2.6, the chlorine was 3.2, and the fluorine is 4.0. Of course, the strongest one. So we chose answer 4. This section of the exam, questions 12 through 15, deal with the physical properties. Which substance cannot be broken down by a chemical change is question 12. Here they're looking for, that's pretty much a definition. If it cannot be broken down by a chemical change, it is an element. So all you have to do is spot the element in the collection. Ammonia, hopefully you remember ammonia as a compound NH3. Water, we all know that's a compound H2O. And propane is an organic compound that has 3 carbons in it and a whole bunch of H's. Since it's an ANE ending, the number of H's is 2 times the 3 plus 2, or 8. But this one, mercury, is an element, elemental substance, so that's our answer. Question 13. At standard pressure, how do the boiling point and freezing point of sodium chloride aqueous solution compare to the boiling point and freezing point of water in a liquid phase? Well, this is pure water. This is an aqueous solution. And in solution, NaCl will form compounds. Will form ions. And if you put ions into solution, it will alter the freezing point and boiling point of the substance. We call that the freezing point depression. Freezing point gets lower. And the boiling point elevation. That's what this question is referring to. So since you've dissolved something in the water, expect a lower freezing point than normal and a higher boiling point than normal. So let's evaluate the answers. Both the boiling point and freezing point are lower. No, they're not. Both the boiling point and freezing point are higher. The boiling point is lower and the freezing point is higher. No, it's the opposite of that. Hopefully number 4 has what we're looking for. The boiling point is higher and the freezing point is lower. Absolutely. Answer number 4. Question 14 offers us a chance to speed up a little bit. The word temperature is given, and they're telling you that temperature is a measure of the. This is clearly a definition question, so let's find the definition. Average kinetic energy of its particles. Stop right there. The answer is number 1. Alright, let's push the page up a little bit so we can see number 15 more clearly. According to the kinetic molecular theory, the particles of an ideal gas do what? Well, kinetic molecular theory, or KMT, you definitely should review this concept if you don't remember it. It deals with the fact that gas particles are in constant random motion, that they collide elastically or bounce off each other, and that they have virtually no attraction for each other. Well, let's start eliminating some of these. Is it reasonable to assume that gas particles have no energy? No, they have the highest energy of the different phases. Have a strong intermolecular force? No, the reason they're gases is because they don't stick together. They are arranged in regular, repeated geometric patterns. No, that's a description of a solid. So 3 is out. Hopefully 4 has what we're looking for. Separated by great distances compared to their size. Sure they are. They're really far apart. Questions 16 through 18 deal with the dreaded kinetics and equilibrium, or K&E unit that we went through. And question number 16 begins by giving you an equation. Notice the reversible arrow, so this is an equilibrium system. It's also a closed system, which allows it to reach equilibrium. But the question, as bulky as it is really simply asking you, what's the definition of equilibrium? Well, equilibrium, if you hunt through these answers, is that system reaches a point where the forward reaction and the reverse reaction have the same rate. So the rate of the forward and reverse reactions are equal. They're not unequal. That wouldn't be equilibrium. That would be disequilibrium. And we also don't know and don't care what the amounts on either side of this are. What's important is that they stay constant, not that they're equal. So saying that one is more than the other or that they're equal is not important when you're discussing equilibrium. The only important factor is the rate of the forward equal to the rate of the reverse. For question 17, in a chemical reaction, the difference between the potential energy of the products and the potential energy of the reactants is equal to. In my classes, I use this equation, where PE stands for potential energy, P for product, minus potential energy of R, reactant, and that expression is used to calculate the delta H of a reaction. What does delta H stand for? That is the heat of the reaction. It's number 3. Question number 18. For a given chemical reaction, the addition of a catalyst provides a different reaction pathway that, and now we have several different choices. What does a catalyst do? Hopefully you recall from class that catalysts speed up reaction rate, so we can get rid of answers 1 and 2 because they're both telling us that the reaction rate is decreasing, which is not true. So how do they do it? How does a catalyst actually increase the rate of a reaction? Well, hopefully you recall from the basic potential energy diagram pictures that we've looked at that this area, the region up on top of the graph, to get from the starting point to the top is called the activation energy. The effect of putting a catalyst into your system will be represented here by the blue line. What the catalyst does is it allows us to reach the top of the curve more quickly by allowing us to get an activation energy that's a little bit lower. So we have a lower activation energy. So our proper selection for this answer is going to be number 4. The catalyst will increase the reaction rate by lowering the activation energy. You can see here the blue line a little bit lower than the red. This third response here increases the reaction rate and has a higher activation energy, just not true. We hit questions 19, 20, and 21, and we enter into the area of organic chemistry. In organic chemistry, of course, we're studying the structures of carbon-containing compounds, and the first question jumps right in. Which atoms can bond with each other to form chains, rings, or networks? Well, that's all about carbon. And just recognizing that we've entered the organic chemistry part of the test is enough, and you easily should spot carbon as your answer. Number 20, a molecule of an unsaturated hydrocarbon must have. Well, what is an unsaturated hydrocarbon? A typical structure of a hydrocarbon, here we're drawing one with 2 carbons, we're going to fill in all the available locations around the carbons with hydrogens, and carbon will accommodate 4 bonds. So if we single bond carbons together, we're going to be able to surround the outside of the structure with a maximum amount of hydrogen. That's called a saturated compound. The only way you get a saturated compound, of course, is if you have single bonds. So as long as that bond is single, you can be saturated. So what's going to cause a unsaturated compound is if you have a double or triple bond between your carbons, then you're not going to be able to put the maximum number of hydrogens. See, we still have space for hydrogen here and here. But in order to put hydrogen there, we'd have to break the double bond. So let's analyze. We have to have at least one single carbon-to-carbon bond. No. If you have single bonds, it could still be saturated. You have to have at least one multiple carbon-to-carbon bond. Yes, that's what's required. If you had 2 or more single carbon-to-carbon bonds, just like number 1 is incorrect, 3 is also incorrect. And 4, 2 or more multiple carbon bonds are not necessary. You only need to have 1 in order to be unsaturated. So that answer is 2. Question 21. Given the formula of the functional group, there's your formula, an organic compound that has this functional group is classified as, well, why ask me? Let's go to the place where all the functional groups are, and we're going to see table R. So let's go to table R. On table R, you'll be able to spot all the different functional groups, and all we're looking for is the one that matches what we were just describing on the previous page. So we need something with 2 oxygens attached to a carbon. One of them is double bonded, and the other one is single bonded with a hydrogen. Here's that exact structure. There's a little more information here. This letter R, as it appears in all these different structures, can be anything. It can be a row, string, some collection of carbons. So everywhere you see an R, there can be more carbons strung out. But here's the key functional group we're looking for, which is the carboxyl group that makes up the organic acid. So we'll go back to our question, and we're going to select organic acid from the list. It's not an aldehyde ester or a ketone. Those are different structures. Although it's handy to have memorized all the functional groups, you can find them all right on table R. This is a peculiar location to find this question. It appears that they've taken a larger question dealing with organic compounds and put it into the 23rd position, and they substituted in number 22 just to make space in the test. It's a little bit awkward to see a oxidation reduction question sticking in the middle of the organic chemistry collection, but they did that to save space, so they can be a little bit tricky in that regard. Which statement describes where oxidation and reduction half reactions occur? Well, the only thing you have to remember for this is that there's a red cat. Reduction occurs at the cathode, period. And what happens at the anode? Oxidation at the anode. So it's a red cat, or reduction at the cathode, oxidation at the anode. So oxidation and reduction both occur at the anode? Not today. Oxidation and reduction both occur at the cathode? Nope. Oxidation occurs at the anode and reduction at the cathode. There's your red cat. They've matched them properly together, so there's your correct answer. And just to be sure, number 4 says the exact opposite, so it is completely wrong. Now we continue our discussion into organic chemistry, and we have question 23, which is asking you to find the isomer. What is an isomer again? Well, it has to have all the same parts, but a different structure. So let's count the parts. There's three parts. There's oxygens, there's carbons, and there's hydrogens. So the structure they gave us, given this formula, has one oxygen. It has 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. And there is a string of 4 carbons present. So I'm looking for an answer that has the same thing. Instantly I notice there's 2 oxygens here, so that guy's out. There's 2 oxygens here, so this guy's out. And both of these match perfectly the count of 1 oxygen, 4 carbon, and 8 hydrogens. However, notice the location of the double bonded oxygen. This double bonded oxygen is on the end of the molecule. So is this one. Now you're saying, of course, they're on opposite ends, but so what? If you look in a mirror, everything's on the opposite side. These are mirror images of each other. This one, however, has its double bonded oxygen located not on the end, but instead in a position that's secondary. That makes it a completely different structure, and that's our correct answer. So it is an isomer of the original structure, and the answer is 2. Now we go back into another redox question. It's actually the second one, but it's just in a strange place. And oxidation reduction, we deal with 2 different kinds of electrochemical situations. There's the electrolytic cell, and then there's the electrochemical cell. Major difference. Electrochemical is a cell in which a chemical reaction will generate electrical energy. And an electrolytic cell, you have to supply the energy. So we go from electrical, usually from a battery, and it generates a chemical reaction that normally would not occur. So we're taking electrical energy and we're forcing a chemical reaction to occur. And in the electrochemical cell, we're taking a chemical reaction and we're getting it to generate electrical current. So the electrolytic cell, that's the one being discussed in number 24, what's happening? Electrical energy is being changed to chemical energy. There's your answer by definition. Who's talking about nuclear? Not me. Who's even mentioning thermal? No, those are from the wrong unit. They're decoys. And this one, chemical energy to electrical energy, that would be the correct answer if that term right there was electrochemical cell. That one. So the correct answer is 2, which describes the electrolytic cell. Question 25, we venture back into organic chemistry. Which compounds can be classified as electrolytes? It's a little bit of electrochemistry. It's also a little bit of acid and base. So we have entered the acid-base zone. Usually we throw the word salt on there also in the name of this unit. And one of the main features of acids, bases, and salts is that they are all considered electrolytes because they all produce ions in solution when they're dissolved. So what we're looking for here, if we want something to be classified as an electrolyte, it has to be either an acid, a base, or a salt. Look at that gift. They actually are giving you the word acid, so you've got to go to number 3. The other 3 possibilities, alcohols, alkynes, and saturated hydrocarbons, none of those match the category of salt or acid or base. Number 26, potassium hydroxide is classified as an Arrhenius base because, well, by definition, this is a definition question, an Arrhenius base is any compound which, when dissolved in water, produces hydroxide ions as the only negative ion. Let's go on to 27. In which laboratory process is a volume of solution of known concentration used to determine the concentration of another solution? You cannot have taken your chemistry course without having done a titration experiment, and this is exactly what's going on in titration. So again, a definition question. And then finally, according to one acid-base theory, an acid is, well, the Arrhenius theory says that acids will produce hydrogen ions in solution. The other theory that they always refer to, they refuse to include its name on the Regents exam, but your teacher might have shown you. It's the Bronsted-Lowry theory, which states that acids donate hydrogens. So if something is an acid, it will donate hydrogen ions. So, acid, hydrogen donor. That's your answer, number 2. And we get to our final 2 questions. 29 and 30 are both from the nuclear chemistry unit. And these are very, very routine questions. Energy is released during the fission of plutonium-239 as a result of the. So all that's needed here is some understanding of what fission is. Fission is a process by which atoms are being split. So we will take a large atom of plutonium-239, we bombard it with some other smaller particle, and it breaks apart and releases huge amounts of energy. So what you're doing here is you're converting matter to energy according to the famous equation E equals mc squared, where the mass conversion is the change and difference in mass between a plutonium-239 atom and the daughter products that are produced when it splits. They collectively will be a little bit less massive than the plutonium-239. That change in mass is converted directly to energy according to this equation. Conversion of energy to matter? No, it's the opposite. And then your decoys, formation of covalent bonds and ionic bonds, these are from a different unit. They have nothing to do with nuclear chemistry. So be aware of where you are in the test. When you get to questions 29 and 30, you're doing nuclear chemistry. And finally, question number 30, atoms of iodine-131 will spontaneously decay when what happens? Well, if they're stable, they have no reason to decay. So answers 1 and 2 are nonsense. They have to begin as unstable nuclei. But do they emit alpha or do they emit beta particles? Let's go to the reference tables and see. This information you'll find on table N, and on table N you look up iodine. There it is right there. And iodine will decay by this particle, a B- particle, which if you look over at this chart on your right, B- stands for beta particle. So let's go back to the test now and select unstable nuclei will emit beta particles. Answer number 4. That completes part A of your exam. We're now going to put up a copy of the answers and let that run for a couple seconds. So if you need to just check answers on your work for part A, you can just freeze the pane on the next couple of seconds. Again, we're going to post the answers to part A so you can check your answers if you've done the work ahead of time. And you can just push pause while I'm writing answers up here. And this is to the 2011 exam. Chemistry. Hope this was helpful. See you next time.